So let's just give them that opportunity. I will be with you just now. Right, it seems that everyone who wanted to join us did join. Welcome, grade 11, and this will be our last online class for this term. If you don't know me by now, my name is Leon, and I am the education specialist for mathematics and sciences. So before we start this online, I would like to does everyone know what is expected of them during the session, as well as what to expect from this session? So if you're struggling to hear me, please make sure that your audio is on and that your speaker volume is turned up. I am aware that the image is a bit, the quality is not that good of the image. I am going to switch that just after the introduction so that the sound will have great quality when we start off with content. So you will be muted. As you know, I do allow some time for questions, and we'll be able to put up your hand, and I will unmute you to allow you to ask your questions on this platform. You can quickly test that out. So you can just click on the hand icon now, and that will put up your hand. And you can click on it again, and it will take down your hand. You can quickly test that out for yourself. There's a lot of hands that I don't see going up or down. Please quickly test that out. Can everyone hear me? So please put up your hand if you can hear me. Okay, great. So it seems that most of you can at least hear me at this stage. Okay. You can download this presentation as well as additional resources in the handout box. So what is a bit different than my previous sessions is that I have this presentation in PDF available for you in that handout box, as well as an extra question that is also about number patterns that we are going to discuss today that I would like you to do on your own. And I have included a memorandum for you over there. So please make sure that you download that during the session, as if we stop this broadcast, you won't be able to download this notes on this platform again. Okay, so while I'm doing this introduction, just click on those files so that it can download in the meantime. We do encourage all our attendees to ask questions and to leave comments. However, should you leave irrelevant or inappropriate comments or questions, you will be dismissed from the session. So during my sessions, I usually answer all my questions, but should you have an academic question still after this session, you're welcome to send an email to academics@impact.co.za. I also look at the question box. So if you're not comfortable to ask your question out loud, you're welcome to type your question in the question box. So I do visit that question box during the session as well to make sure that I answered all of those questions. Should there be unanswered questions, I will send you feedback via an email. If there was unanswered questions and I didn't get back to you, you're welcome to send an email to info@impact.co.za. So all of our previous recordings of the online sessions is available on our website, and I will just remind you about that at the end of the session as well. Okay, so quickly show me, is everyone ready for the session? Put up your hand, show me that you can hear me and you're ready for us to move on. I want to see everyone's hands, please. There we go, that looks much better. Okay, you're welcome to take down your own hand. Awesome. Okay, so guys, I'm going to switch off my video for now, just to allow that the quality of the sound is a bit better, but I will be here all the time. All right. So today I decided to have a look at number patterns. And as you know, this is the last part of the work for term 2. So we spend a lot of time on trigonometry and detail into functions and so on. So number patterns is the last part. You actually could have done that in term 1 if you were enrolled at a school as well. So this might be some revision for you on that part. So I mentioned previously that this will be our last session for this term. So what will happen is that today will be your last online lesson for the next 2 to 3 weeks. So in July, the 1st of July, the June examinations will be made available to you. So as you know, you did not write the June examinations as a formal assessment, but we decided to make that available for you for revision purposes. So I would really like all of you to prepare for that as if you would prepare for an examination. Write the June examination on your own time and then mark it by making use of the memorandum that we will also provide to you. Then after the little holiday break that we give you, you will get information regarding revision classes of the June examination. So then we will do a June examination revision online class, and then we're going to start with term 3 work. So for this week and for the rest of this week and next week, take a little bit of a break and then start to prepare for your June examination practice paper, and then you jump away and work hard again. Okay, so like I said today, I decided to let us look at number patterns again, and number patterns will be assessed in paper 1. So the topics that you have to do or to cover in number patterns are to determine the general term and solving problems relating to arithmetic sequences. This is your typical linear sequences that you've done, or your linear number patterns that you have done in grade 10. The only thing that is added to that is quadratic sequences. So you're not really asked to find the sum of, so you're not going to work with series of patterns. You're only going to look at general, meaning the equation that explains this sequence or this number pattern. So during this session, you will see that I make reference to arithmetic sequences or linear sequences that you are used to. So arithmetic sequences is a term we use from grade 12 onwards, and you might see that in your grade 11 examinations and tests as well. So I thought it's well to just expose you to the two terms that you might see when you do arithmetic sequences or when you do number patterns. Okay, so the one is arithmetic sequences that you've done in grade 10, and I am going to spend a little bit of time on that, just revising. And then, of course, the new part, quadratic sequences. So let's look at arithmetic or linear sequences. So these are number patterns where there is a common difference. What is a common difference? So that is when I take my second term. So let me just get this nice indicator here for you. So I take my second term and I subtract my first term. That answer that I get over there will be the same as if I take my third term and subtract my second term. Do you see the difference? That is why we're subtracting. And common means that the answers that we get is the same. So we have a common difference. And the symbol that we use to actually indicate that is D. So how do I determine if a number pattern is a linear sequence? So let's, for example, take this given sequence, 5, 9, 13, 17. And in a test or an exam or in a task, they will not tell you this is a linear sequence. Sometimes they are nice and they do that, but that is not something that you can rely on. Okay, so they give you the following sequence and they say determine the general term, and that is a question that they usually ask. And before you can do that, you need to find out what type of number pattern is this. Is this an arithmetic or a linear sequence, or is it a quadratic sequence? So you need to test for either one of those two. So to find out if this is a linear sequence, you will subtract the second term, the first term from the second term and the second term from the third term. So I've just made it a bit bigger. This is the sequence that was given. So what I'll do is I'll take the second term, subtract the first term, and I get an answer of 4. I'll take the third term, which is 13, minus the second term, which is 9, and it will give me a 4. And if I do the fourth one as well, I say term 4 minus term 3, I also get an answer of 4. So do you see the difference between the terms gives me the same answer, which is a common difference. So there I've shown you that all of them are the same. So it means that my symbol D is equal to 4. That is my common difference. So here I've given you an equation, and some of you never saw this before as you didn't use equations like this in grade 10. In grade 11, you are allowed to use this, but remember that no formula sheet is provided to you. So you need to know this off by heart if you want to use it. Okay, so the equation for an arithmetic or linear sequence, and it's specific to this type of sequence, is the following. Tn, which is representative of my general term, is equal to A plus n minus 1 D. So D, you already know, is your common difference. So given a quadratic, not a quadratic, a linear sequence, you can actually already calculate D. So let's just define all of the symbols in this equation. So Tn, I already said, is your general term. And the general term is just a fancy word to say they want to know the formula of this equation, of this sequence. Which formula actually represents this sequence? A is representative of your first term in the sequence. n is the number, the term number. So if you want to find out what is term 5, in the n you will put a 5. D, I've already mentioned, is the common difference between the terms, and you can actually calculate that as we've done before. Okay, so how is this questions asked in grade 11? And I thought it well to do an example out of a question paper so that you are exposed to how it can be asked and assessed. And I've taken this from the DBE November examination paper 2 of 2018. Sorry, there should be paper 1, correct, because this is asked in paper 1. So they have given you a linear pattern, and how very nice of them to actually tell me that this is a linear pattern. So they've given us 7, 2, and -3 over there. So you should please excuse my writing as I'm writing with the mouse at the moment. Okay, so because I'm working with a linear pattern, I already know that I can make use of this equation. Right, and I can calculate my D because I have all of these terms. And you can do that on the side of the paper or as part of your question, it doesn't matter. So you will have 2 minus 7. Remember, it's the second term minus the first term, not the other way around. And you will get -5. Then you can take the third term, which is -3, subtract the second term, and you will have a -5 again. And this just proves that it is a linear pattern, as they said. So D is -5. Okay, so D is -5 in this case. The other one that I can just read off from here is my A, which represents my first term. So the first term of this sequence is 7, and you can just substitute it into the equation. Right. So I've said this is the equation that you will use. We can see that A is 7, and we can see that D is -5. And I've shown you all of this ugly writing over here, how I got to that answer. And now I'm just going to substitute it into this equation. So I'm going to substitute the 7 into the A, plus n minus 1 stays as it is because the general term will have a variable, and the variable is n. So finding a general term, you will never substitute n. You will only substitute A and D. Okay? And then D substituted as -5. I'm just simplifying this a bit. 7 and then -5 times n is -5n. -5 times -1 is +5. And then just saying 7 plus the 5 is 12 minus 5n. And this is your general term. Tn is equal to 12 minus 5n. Now they say, calculate the value of T20. Do you see that they substituted a 20 in the place of the n? You have this equation. You've just calculated that. You need to do what they tell you. It means that they want to know what is the value of the 20th term. So taking this equation, you're just going to substitute your n with 20. Your answer will be -88. This means that if you continue with this pattern here at the top and you get to the 20th term of this pattern, your term will be negative. So 3.1.3 says which term in the pattern has a value of -138. It means that this entire term, this entire general term part is actually a value. So you're going to substitute this value into the Tn and you're going to solve n because I want to know the term number, which is equal to negative 138. Like I said, you want to calculate your n. You're going to substitute this value into the entire Tn space is equal to 12 minus 5n, and you're going to solve n, which is your term number. So I've taken the 12 over to the other side, so subtract over here, and then divide both sides with a negative 5 to get to n is equal to 30. It means that my 30th term is equal to negative 138. I'm going to repeat that. It means that my 30th term is equal to negative 138. Right. We can move over to question 3.2. So 6, 2x plus 1, and 3x minus 3 are the three first terms of a linear pattern. Now, this is very important information that they've given us, because this gives us a clue as to how we can go about working with this information. And they want to find the value of x. So, firstly, you need to say this is term 1. This entire expression over here represents term 2. And this entire expression over here represents term 3. Okay, so you have meaning it actually fits into the role of finding a common difference. It means that if I subtract term 2 from term 3, it should be equal to term 2 minus term 1. And that is exactly what you're going to use. And you will see you will only have one variable, which is x in the end. So writing it down, term 2 minus term 1 is equal to term 3 minus term 2, because it is a linear pattern which has a common difference, meaning the difference of these two terms is equal to the difference of these two terms. And I'm just going to substitute it in there. So term 2 is 2x plus 1, subtracting the first term, which is 6, is equal to the third term, which is 3x minus 3, subtracting the second term, which is 2x plus 1. And then I'm just going to simplify. So I first multiplied in this negative over here, so it becomes negative 2x. Taking the 6 over, just adding it to, I just simplified here, 1 minus 6, which is negative 5. Simplifying even more, and then in the end, solving your x is equal to 1, and that is what they asked. They asked me to find the value of x. Right. Okay. Grade 11s. I am going to allow some time for questions now. Is there anyone that has a question regarding question 3 over here? Welcome to put up your hand if you do. I'm just going to check in the question box as well. I don't see any questions popping up there either. So it seems that you're quite comfortable. As I said, you have done this in grade 10 as well. So I'm going to move on to grade 11. Okay, so still in paper 1, as it's part of number patterns, is the quadratic sequence that we're going to work with. And quadratic sequence is actually gives you a clue as to what we're going to work with. So with linear patterns, we worked with a common difference after just checking that difference for the first time. Now we're going to work with a second common difference, and I'm going to show you that by making use of a question that I found on the internet as well. Firstly, this is the equation of a general term, of a quadratic sequence. And the quadratic comes from this n to the power to the square. So an squared plus bn plus c. And this is actually also the equation that you can use with parabolas, right? It's not new. You still need to remember it because you don't get a formula sheet. Okay, so the general term, still Tn, is equal to an squared plus bn plus c. Right, like I said, this is still the general term, and they like to ask you the general term, and that's the biggest difference of your approach and your calculations from this to a linear sequence. So like I said, I'm going to use an example to actually explain this quadratic sequence to you. So they say, find the general term and then the number of terms in the sequence. Do you see they only give you the sequence? They don't tell you this is a linear sequence or a quadratic sequence. You need to test it. And what will be your first step? My first step will be, okay, let me see if I can get a common difference. 10 minus 5 is 5. 17 minus 10 is 7. Oh, there's a difference. Do you see that that is not a common difference there? So you are going to do that twice. So here I've shown you doing this difference that we've done with linear patterns, and I see that my difference that I get is not a common difference. Then I calculate a second difference. So the difference of the difference. 7 minus the 5 is 2. 9 minus the 7 is 2. And then only I have a common difference. And we call this a common second difference because we've done that twice. Twice. Right, and a common second difference shows me that I'm looking at a quadratic sequence. Okay, so the next part that I'm going to show you is another 3 equations that you will have to remember. It's not going to be given to you. Even in grade 12, when you receive a formula sheet, they will not give these 3 formulas to you. You need to know this off by heart. 2a is equal to my first term of the second common difference. So 2a is equal to 2. 3a plus b is equal to the first term of the first difference, in this case, 5. A plus b plus c is equal to the first term of the original sequence over there. Right, so these 3 equations, I'm just saying it again, will not be given to you. It's part of your calculations and steps and thinking that you'll have to do. So how do I use this to find my general term? Because the question says, find the general term of the sequence. Let's look at the first one. I said 2a is equal to the first term of the common difference, which will be 2a is equal to 2. I will now solve a, so divide 2 on both sides, and you will get that a is equal to 1. Then I'm taking my second equation here. 3a plus b is equal to the first term of the first difference, which is 3a plus b is equal to 5. Now, I've already calculated a in my previous step, so I can substitute the value of a as 1, and then I can calculate b. Now I have the value of the variables a and b, and I can actually substitute that into the third equation, which is a plus b plus c is equal to the first term of the original sequence. So a plus b plus c is equal to 5. I substitute the value of A, which is 1. I substitute the value of B, which is 2, plus C is equal to 5. And then I solve C, which is 2. So this A, B, and C that you have just calculated can fit into the general term of a quadratic sequence. So do you see A, n squared, plus B, n, plus C? There is your 3 variables over there. Just substitute the values that you've calculated in there. And there you have your general term of this sequence. So we've answered this part of the question where it says find the general term. And then the number of terms in the sequence we didn't calculate yet. And I said that the number of terms is still representative of n. So that did not change. N still represents my number of terms. So I need to use my general term. I'm still going to use my general term to calculate n because that's the only place that I have linked to this sequence over here. They have given me the last term of the sequence over here. It means that I want to know how many terms are there, or what is the number of the last term, the n of my last term, which has a value of 10,202. And remember, when we talk about a value of a term, this entire Tn can be substituted with that value. So you're going to take your general term. You will substitute your value of the last term in there. You will simplify it a bit. So you will say 0 is equal to n squared plus 2n, and then plus 2 minus this one coming over here will be 10,200. And then you're going to factorize. So there's your algebra slipping in here again. You will never get rid of your algebra. That's why you need to know your algebra, how to factorize, how to simplify. That will always be part of any part of mathematics. Right, so how do I factorize a quadratic function? I will have my 2 brackets, n. This negative tells me that the signs inside the brackets must be different. And then find how to get these two. Right, so n is equal to 100 or n is equal to negative 102. Now, which one is applicable here? I can't say there is 100 or maybe 102 terms in this sequence. No, you need to decide the negative terms. If I tell you, please show me a negative 102 terms, how in the world are you going to show me that? You can't have negative terms. This does not show direction, as in physical sciences, those of you who have that. Here with sequences, you have terms or you don't. You can't have a negative number of terms. I can't owe you any terms. So when you get to a question like this, the answer that will give you negative number of terms is not applicable. So this means that there are 100 terms in this sequence. Right, is there any questions regarding this quadratic sequence that we have done? And you will see that the extra question that I've added to the handouts is another quadratic sequence question that you can work through and also look on the memo as well, how they got. So there's no questions in the question box. I don't see any hands up. This is the last call, guys. I'm going to move on. So ask your questions. Nothing, no hands going up, nothing in the question box. Okay. Right, so I've added there for you 2 links on the internet regarding number patterns. Please go and have a look at it. It's quite nicely set out. And then I've also added these YouTube links to our online platform, that guided learning platform video. So you're welcome to also look. Remember that you can also access all of our past videos or the recordings of our past videos and lessons that we have done. So when you're doing revision, you're welcome to have a look at those videos as well. Right, and I've shown you the steps on how to get it on the website. If you're not registered at Impact and you would like some more information, you're welcome to send an email to info@impact.co.za. Right, grade 11s, thank you so much for joining in this afternoon. Always a pleasure to have you here. I hope you learned something today and enjoy your small break. Be safe, enjoy your families. Bye.